Hello. Today you'll be learning about lenses in this three-part mini-series. The first part, I will teach you the basic understanding and mechanics of lenses. And then I will also teach you the two main equations used in lenses problems. First, there are two types of lenses, a converging lens and a diverging lens. A converging lens causes incident parallel rays to converge at the focal point, while a diverging lens causes incident parallel rays to diverge once leaving the lens. Here's what I mean. A converging lens, as you can see on the left side, is shaped like a football, and it takes parallel rays coming in from the left side and diverges it towards what we call a focal point, which is where the light crosses the principal axis, this line, this faint line right here, on the right side. A diverging lens, on the other hand, takes the rays from the left-hand side and diverges away from the rays from the focal point, which would be right around here. Key terms to remember. A focal point is a point where the light crosses the principal axis after coming parallel into a converging lens. The focal length is the distance from the focal point to the lens. The principal axis is the line passing through the optical center and centers of curvature of the faces of a lens or a curved mirror. The real image is the image produced when actual light converges after leaving the lens. What I mean is a real image would be formed here where the light converges on the focal point. A real image would not be created here, but instead you would get a virtual image, an image produced from the tracing back of refracted light. Seeing how the light does not converge on the right-hand side, that means no image is produced on the right-hand side. But instead you trace back these lines that are refracted, so you would get an image right here, where these lines would imaginarily cross on the left-hand side. The object distance is the distance from the object being used to the lens. The image distance, on the other hand, is the distance of the created image to the lens. The magnification is the ratio of the size of an image to the size of an object. Equations. The thin lens equation is the first one that we will be using. It is 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length. And the second equation is the magnification equation. And magnification equals the image height over the object height. And that is self-explanatory what the image height and the object height are. Is also equal to negative the image distance over the object distance. Key things to remember is that the focal length is positive for a converging lens, while it is negative for a diverging lens. The image distance is positive for a real image formed on the right of the lens, and it is negative for a virtual image formed to the left of the lens. The object distance is positive if the object is to the left of the lens, and the object distance is negative if the object is to the right of the lens. The magnification is positive for an image that is upright with respect to the object, and negative for an image that is inverted. This concludes the first part of our three-part series, and I hope you'll tune in for the next part where I will show you a computer simulation of a lens in action, both diverging and converging.